Welcome back. Today, we're unpacking something that could literally revolutionize how we share information. We're looking at CSDL, which stands for Constructive Signal Design Language. If you've ever tried to get an AI to build a presentation for you, only to end up with a chaotic, confusing mess, you are gonna absolutely love this. It's a verifiable visual language designed specifically to bridge the gap between humans and AI. We really have to start right here because, let's be honest, this is the universal pain point we all share. You got this highly technical, incredibly important concept to share, right? But by the time it actually makes it into a slide deck, it just becomes generic, it's cluttered, the complex idea just gets buried under a mountain of visual noise, and worst of all, it's incredibly difficult to reproduce or update later on without breaking the entire layout. Okay, let's dive into this. Look at how this beautifully visualizes both the exact problem and the solution. Over on the left side of that funnel, you see all those scattered gray shapes, right? Rectangles, circles, just kind of floating around randomly. That is your typical noisy presentation. It's scattered data. But watch what happens as it moves through the CSDL framework. All of that noise is funneled down, refined, and translated into one single dominant red square on the right. One pure, clear signal. CSDL acts as a versioned, machine-readable visual language for fields like AI and software engineering, taking scattered noise and turning it into focused clarity. So here's our roadmap for this explainer. We'll start with the presentation problem, move on to constructive signal, explore a closed visual grammar, see how recipes turn into structure, check out human and agent collaboration, and finally wrap up with the practical promise. And honestly, providing a clear modular scope right up front like this perfectly mirrors the structured philosophy of CSDL itself. All right, section 1, the presentation problem, and exactly why our complex ideas tend to get lost in translation. This quote hits the nail on the head regarding our current trap. Right now, we generally do one of two things. We either force complex ideas into rigid, stiff templates where they just don't belong, or we use generative AI and rely on lucky prompts. Essentially crossing our fingers and hoping the AI hallucinates a layout that makes some kind of sense. Neither approach is reliable, and they definitely fail both the human trying to explain the idea and the generative model trying to build it. Which brings us to our second section, constructive signal and style, or the aesthetic of clarity. Let's look at the foundational design philosophy here. CSDL operates on a very specific visual direction called quiet modular. Think of it as a baseline of calm. It uses warm restraint, highly functional geometry, and, this is key, a generous amount of negative space. By keeping things quiet and restrained by default, the language allows for rare moments of strong emphasis to truly pop. The design is meant to be entirely functional. It lets the data, rather than the decoration, do the talking. Now, what's really interesting about this slide is seeing quiet modular actually in action. Notice the generous negative space. We're talking 50 to 75% negative space across the board. Look at the progression from level A, which is super quiet, all the way up to level C, the dominant signal. Along the bottom timeline, you can see how the semantic emphasis builds, starting from a tiny red square and growing into a massive red triangle. But notice how the underlying visual language never changes. The intensity grows, sure, but the grammar remains completely consistent. That strict consistency leads us perfectly into section 3, a closed visual grammar, moving way beyond fixed, boring templates. So instead of templates, CSDL uses a closed semantic grammar. This means every single geometric shape has a strict, specific job. Anchors, they hold your core ideas. Vectors, they show movement or relationships. Frames are used to establish scope, and signals are used exclusively to direct the viewer's attention. Geometry in this system isn't just there to make things look pretty. It always plays a strict semantic role. And that meaning is built from exactly 15 public components, which you can see clustered right there in the dotted circle. Just 15. Check out the flow of the diagram. A human's idea attaches to a black anchor block. Then, that anchor uses supporting structure from those 15 components to drive the viewer straight to the dominant red signal. You don't get 1,000 random shapes or fonts to choose from. You get a precise, limited toolkit designed for pure clarity. Now that we have our basic vocabulary down, let's look at section 4, recipes turn into structure. This is where we move from intent to applied mechanism. 23. This is a vitally important number to remember for this system. There are exactly 23 evidence-backed recipes within CSDL. The system isn't just randomly guessing what might look good on a page. These are proven formulas explicitly designed to solve very specific explanatory problems. Let's see how those 23 recipes actually work. Over on the left, you see explanatory problems, proposition, comparison, sequence, topology. When you build a presentation using CSDL, you don't start by demanding a specific 3-column layout. You start with your semantic intent. Are you trying to compare two things? Well, you pick your intent, and that feeds into one of the 23 recipes in that red box. The recipe then selects the proper visual mechanism, and those 15 components construct it. Let's move to and see how this builds into a highly predictable 5-step pipeline. First, you start with semantic intent. That routes to one of the 23 recipes, which then converts into a prompt DSL. From there, it enters a deterministic generation package, and finally, it results in a validated output. It's a clear pipeline that turns a human thought into a completely verifiable machine-readable output. And here is that exact pipeline mapped out visually. Notice the text running along the very bottom there. This pipeline guarantees exact content, source provenance, and total reproducibility. Because the whole thing is deterministic, you could reproduce this exact same frame tomorrow or a year from now, and you won't have to worry about an AI suddenly hallucinating new fonts or throwing out weird layout choices. Which brings us to the real climax of this explainer, Section 5, Human and Agent Collaboration. This is how humans and AI finally get a shared, reliable workspace. Inside this system, there's a very clear division of labor that plays to the strengths of both parties. The human is entirely responsible for strategy, choosing the claim, providing the evidence, and determining the overall intent. The agent, the AI, is responsible for execution. It selects the recipe, constructs the components, and validates the output. But here is the absolute golden rule. Neither side is allowed to invent copy, data, components, or recipes. And this brilliantly illustrates how that collaboration works. The human is on the left, the agent is on the right, and they sit on a single, continuous axis, perfectly united by that red signal in the center. They are completely aligned because Markdown remains the ultimate source of truth. The human writes the Markdown, and the AI agent reads and constructs from that exact same Markdown. No guessing, no translation errors. Let's bring it all together in our final section, the practical promise. What does a verifiable design language actually get us? Just walk through this upward trajectory with me, moving step by step toward that final red signal arrow. You define an idea, you select a mechanism, you bind the exact content, you construct, you validate, and only then do you publish. And the ultimate result? It is radically clearer for people to understand and infinitely more reproducible with generative models. Because the output is strictly bound to exact content and validated before publishing, CSDL truly turns visual style into a verifiable design language. And the proof is right here in front of us. What you're looking at is an overview of the exact 7 frames we just walked through, completely generated using this very pipeline. You can really see that quiet modular aesthetic at work here, the warm restraint and functional geometry holding up beautifully across an entire complex explanation. It's coherent, it feels trustworthy, and it is incredibly focused. So, the crucial point is this. If you take away absolutely anything from this explainer today, let it be these 3 simple, powerful statements that form the very core philosophy of CSDL. One idea, one mechanism, one signal. By forcing us to isolate our intent and strip away all that decorative noise, CSDL ensures that the actual message survives the medium. I want to leave you with a final thought to chew on. We spend so much time fighting with our tools, right? Trying to get them to just understand our intent. But with a system where Markdown is the absolute source of truth and geometry has strict semantic meaning, how will a verifiable visual language change the way you explain your next big idea to an AI? It's a whole new frontier for clear communication. Thank you so much for joining me in this explainer today. Keep learning, keep demanding clearer communication from your tools, and I'll see you in the next one.